Hello lovely guys, how you are doing? Back again with the video of Simple Machine. This is part 3. In the previous video we discussed about AME, why is AME affected by friction. Then also we discussed about why AME is always less than expected. What do we mean by AME equals to 2? And these all things we studied before. Also, we discussed about why ME is unitless quantity. Now, moving to next one, we have got velocity ratio, which is simply known as VR. It's not a motorbike, obviously. It's not funny though, but just a kind of joke, my guys. I don't know why I'm feeling like coughing and all. Okay, grown old, right? Okay, so VR, it is defined as ratio of effort distance to load distance. Once again, as you can see over here, it is the ratio of two distances. So we can say that once again, unit of effort distance is meter, load distance also meter, meter and meter gets cancelled, so it becomes unitless, no unit of VR. Like in case of MA, it doesn't have any unit. So coming to VR is not affected by friction. Unlike mechanical advantage, VR is not affected by friction. You know why? Because it is the ratio of fundamental quantity, that is length, and length doesn't depend upon any other factor, or it is not affected by any other factor, since VR is just the ratio of two length, and length is not reduced by the friction. Length does not depend upon any other quantities, so we say that VR is not affected by friction. From here, if we compare MA and VR in a machine is always greater than MA in a machine, because MA is affected by friction, but VR is not affected by friction. So we say VR is always greater than MA in a simple machine and all. Is that clear, guys? Do you have any point over here? No point, I guess. So coming to next point about VR, very important point. What do you mean by VR of a machine is 2? VR of a machine is 2 means that effort distance is greater than load distance by 2 times. Or you can say, if load distance travels some distance, or if load travels some distance, then the distance traveled by effort is always greater by how many times? 2 times. That is what we understand from VR of a machine is 2. If I want to represent in a diagram over here, suppose this is the effort region over here, and let's say we have kept load. If this load is present 1 centimeter away from fulcrum, and we are using the machine whose VR is 2, then effort is always applied at 2 centimeter away from the fulcrum. For your information, do not always assume the distance between fulcrum to effort is ED and the distance from fulcrum to load is LD. It is sometimes the distance traveled by load and effort is also represented in this way. Here we have load, here I am applying effort. After applying effort, both of the lever, it tends to come at this position. The load will be shifted at this region and effort will lie at this region. Now from this point A to B, this can also be regarded as effort distance. From this point C to D, This can also be regarded as load distance over here. Please do not get confused at this point. When you apply the effort, the lever gets balanced, and from this point the distance traveled by load in upward direction and effort traveled by downward direction is also regarded as effort distance and load distance respectively. Is that clear? Okay, do not get confused in this point over here. Sometime this distance, this gap over here is also represented as effort distance. This gap over here is sometimes referred as load distance. Please do not get confused at this point. Finally, we have the last quantity, that is efficiency, which is represented by a symbol over here eta, where the symbol of efficiency is similar to N, but the only thing that you do is extend the latter part. Okay, it's similar to letter N, but we are just extending the latter part over here. Okay, so efficiency is given by in output work by input work into 100% every time. So what is output work then? It is the work done by a machine which is given as load into load distance. Input work is the work done in a machine by the operator, by the worker. So we can say that input work is given by effort into effort distance into 100%. If I separate these two fractions over here, I get load by effort into load distance by effort distance. We have studied that this quantity is given as MA. So I just replace it by MA into load distance by effort distance into 100%. Once again, if you come back to the topic that VR is ratio of effort distance by load distance. If I reciprocal this, I get, if I reciprocal, okay, after reciprocally, if I reciprocal this, what I get, 1 by VR equals to load distance by effort distance. Reciprocal meaning I change numerator to denominator, denominator to numerator. That is regarded as reciprocal. So I get 1 by VR equals to load distance by effort distance. So from here I can write MA into 1 by VR equals to 100%, which is also given by MA by VR into 100%. And remember, the question will be asked, prove that efficiency equals to MA by VR into 100%, or show the relation between MA, VR and efficiency will be asked during your examination. So pay attention in that question. Okay, coming to next topic, we have got efficiency is also affected by friction of a machine. Okay, so we say that if machine is 80% efficient, so what we understand from machine is 80% efficient, out of 100% work done in a machine, 80% becomes useful work. 80% of the work become useful, and rest of the 20% it is wasted in form of heat energy due to friction, or to move part of a machine. Obviously no machine is massless. To move the machine, some amount of work has to be done. Out of 100% input work done by the worker, 80% becomes useful, 20% is wasted in form of heat energy due to friction produced in a machine, and we don't say or over here, and to move part of a machine. This much for today. See you guys in next video of simple machine. Bye bye. Have a good day.